This is Algebra 2, Lesson 70 on page 294. All right, we have done this type of a problem before. It's where we're solving for one of the variables in an equation. I've written the steps down on the board to which we will follow. The difference in this lesson is our equations are more complex or more abstract, okay? So the first thing we're going to do is we're going to eliminate the parentheses. And the way we will eliminate the parentheses is typically through distribution. We're going to distribute a term that's on the outside of the parentheses so that we eliminate parentheses. Then, because we have an equal sign in these equations, we're going to eliminate the denominators. Remember, if we have an equal sign, we eliminate denominators by multiplying by every term by what would be the common denominator. So equal sign, eliminate denominators. Equal sign, we're eliminating decimals, right? That's a rule. After we eliminate the denominator, so you're going to be solving for one of the variables. Let's say it's b. If we're solving for the value of b, then we want to isolate every term that has a b in it to one side of the equal sign. So through addition and subtraction, we're going to move the terms, every term that has a b on one side of the equal sign, on the other side of the equal sign, every term that does not have a b in it, the variable b. All right, so whatever variable we're solving for, every one of those terms on one side of the equal sign, every one of the terms without that in it on the other side. Then, once we've isolated those terms, we're going to factor out the term we're solving for. So we're going to factor the b out of every term on that side of the equal sign. When you factor out, it's as though you're dividing by that term. Once we've factored out the b, then you're going to b times some polynomial. It might be a binomial, a monomial. And that is what we're going to divide by on both sides. And then we'll end up with b equals some fraction. All right, so let's begin this. We've done this before. These are just more complex equations. Look at example 1. X equals p. We're solving for b. I always write that down. X equals p, open parentheses, 1 over a plus m over b. 1 over a plus m over b. All right, I'm going to eliminate the parentheses by distributing p to both terms. It's just like p over 1, so I'm multiplying p times each of the numerators. So I have x equals p over a plus pm over b. All right, step 1. Step 2, I'm going to eliminate the denominators. I eliminate the denominators by multiplying every term. Remember, that's the rule, or else I change the equality. I have to multiply every term by the same value. All right, so my common denominator will be a times b. That's what I'm going to multiply every term by, a times b. A times b, a times b, every term. But remember, I'm eliminating the denominator. So before I multiply, I simplify. That's right. I can only simplify terms that are multiplied. All right. So this one, there's no denominator, no simplifying. It's just ABX. This term, we're going to simplify. Our A's eliminate. I'm left with PB. This term, this last term, my B's eliminate. I'm left with PMA. All right. Now, I've eliminated the denominator. Now, I'm solving for b. I want every term that has a b in it on one side of the equal sign. So here's a term with a b, here's a term with a b. I'm going to move this one to the left. It's added. I do the inverse operation. So I move it through subtraction. I'm left with ABX minus PB equals PMA. All right. Now, my terms with a b in it are isolated. I'm going to factor the b out of each term. When you factor out, it's as though we're dividing each term by that value. So when I divide that first term by b, I'm left with ax. When I divide that term by b, I'm left with p equals pma. Now, b times a binomial equals however many terms, right? Doesn't matter how many terms we have. I'm dividing by what's not b. Remember, I can only simplify terms that are multiplied. That's why these two eliminate, because b is multiplied by that. So what does b equal? It's PMA over AX minus P. This is important because we're going to be doing this type of operations with trig, sine, cosine. We're gonna have to know, factor something out, isolate, all right? So if you can remember these rules of algebra, it really helps to solidify these rules of algebra. All right, let's look at your next example. Which happens to be your last example. All right, we are going to solve for C. All right, I always write that down so that I know. The equation I have is XP equals M, open parentheses, B over 1 plus C, plus A over P. All right, I'm going to eliminate the parentheses by distributing M to both of the numerators. I'm left with XP equals MB over 1 plus C plus AM over P. Now I'm going to multiply by what would be the common denominator. It's both of these multiplied. It's 1 plus C times P. All right, so I'm going to multiply every term by 1 plus C times P. All right, so P times 1 plus C. P times 1 plus C. All right, this is 1 plus C times PXP. Now I'll need to go back and distribute that. All right, before I multiply, I simplify. All these terms, MP is multiplied by P is multiplied by 1 plus C. So because they're multiplied, I can simplify. P will eliminate here. So here I'm just, this first term on the right-hand side of the equal sign, I'm just left with MBP. Now, don't forget this plus sign. This is plus AM when I distribute it. Positive AM times positive 1 is positive AM. Positive AM times positive C is positive AMC. Now I'll go back and distribute the PXP. All right, so it's PXP plus CPXP equals MBP plus AM plus AMC. All right, I'm solving for C. I want every term with a C on one side of the equal sign, every term that doesn't have a C on the other side. All right, here's a C, here's a C. I'm going to move this one to the left through subtraction. So I'm going to subtract, I'm going to make that P squared X. Subtract P squared X to eliminate on the left-hand side. I'm going to subtract AMC on both sides. All right, so I have C P squared X. I'm going to write that as C P squared X minus AMC equals MBP plus AM minus P squared X. I'm going to factor the C out of both of these terms. I'm left with P squared X minus AM equals MBP plus AM minus P squared X. I divide by what's not the value of C. P squared X minus AM. P squared X minus AM. These cannot eliminate because they are tied through addition and subtraction. All right, these cannot be eliminated. So what's the value of C? It's MBP plus AM minus P squared X over P squared X minus AM.